everyone, Miss Meek here, and today we're going to be talking about repeating decimals. Repeating decimals. A repeating decimal is a decimal that doesn't end. Okay, it keeps going and going forever, repeating a same pattern of numbers or repeating the same number over and over again. This is different than a normal decimal. A normal decimal is called a terminating decimal. That terminating decimal means that the division ends, and all that is repeating after it are zeros. But a repeating decimal is going to have a number that keeps repeating over and over again. Just to remind us of a method to turn fractions into decimals is tie-bow. It is a division problem where the numerator goes inside and the denominator goes on the outside of our division problem. So tie-bow is just a kind of funny little way to remember where the numbers go. It stands for TI, stands for top inside, so the top number, the numerator goes inside of our division house. And then BO stands for bottom outside, meaning that your denominator is going to go outside of your division house. So now that we remember this, let's go ahead and start dividing. I have 1/3. So I'm going to divide 1/3. Remember that my top number, my numerator, is going to go inside, and my bottom number, my denominator, is going to go outside as my divisor. 3 does not fit into 1, so I add a 0. I add a decimal point here, and then I add a 0 so that my division can continue. I ask myself, how many times does 3 fit into 10? Well, 3 fits into 10 3 times. 3 times 3 is 9, and I subtract. I get a 1. I bring down the 0. How many times does 3 go into 10? 3 times. 3 times 3 is 9. I subtract, I get a 1. This is kind of starting to feel a little repetitive, a little familiar, as I continue to divide the same thing over and over again, and I subtract, and once again, surprise, I got a 1. Okay, so what starts to happen in your division is the same pattern of subtraction and multiplying and dividing starts to happen over and over again. As you can see, it was how many times does 3 fit into 10? 3 times. 3 times 3 is 9. Subtract, I get a 1. How many times does 3 fit into 10? 3 times, and so on. It starts to continue to repeat the same thing over and over again. When you see that, that means you have a repeating decimal. Now, we can't just write however many 3s that we decide, okay? There's actually a proper way to show that you have a repeating decimal. What you do is you take and you write your decimal. You can, depending on your decimal, you can write it to the tenths place or the hundredths place. And then we put a bar over the repeating digit. That bar is called a bar notation. That bar notation indicates that that digit that it's over is the repeating digit in the decimal. If you don't put that bar, we will think that it's just 33 hundredths, that it's not repeating. But unfortunately, this was a repeating decimal, and so that is going to be read as 33 hundredths repeating. That bar notation indicates we have a repeating 3 on the end of our decimal. So our final answer is 33 hundredths repeating. Let's do another one. So here, over here, I'm going to divide. My 5 is my dividend, so it goes in. My 6 is my divisor, so it goes on the outside there. And I start to divide. 6 does not fit into 5, so I put a 0. Add a decimal point. Add a 0 to continue the division. 6 fits into 58 times. 6 times 8 is 48. I subtract and I get a 2. Add a 0 to bring down. 6 goes into 23 times. 3 times 6 is 18. I subtract. I get a 2. Bring down a 0. 6 goes into 23 times. 3 times 6 is 18. I subtract. I get a 2. Do y'all start to see the pattern? It's starting to form there. 20 minus 18. 20 minus 18 over and over again. That means that we have a repeating decimal. Now this one's a little different than the other one because we notice not both digits are repeating. Only one is repeating. So when I go to write this decimal, I need to make sure I write it and only put my bar notation over the repeating digit. It's not going to go over the 8 because the 8 is not repeating. Only the 3 is repeating. So notice my bar notation is only over the 3 and not both the 8 and the 3. So you have to make sure you put the bar only over the repeating digit. All right, guys, so that is how to determine if you have a repeating decimal or not when you are dividing out a fraction. I hope that this helps clear up any confusion you have about repeating decimals. If you would like to watch more videos about turning fractions into decimals, I have one posted on my YouTube channel, so check it out. All right, I hope this helps. I'll talk to you later. Bye.